another way we can design a program, which is algorithm and pseudocode. So let's define pseudocode. The word pseudo means fake and pretentious. So think of pseudocode as kind of fake codes. They are not like programming languages that require syntax, but they are just a way for us to write down the algorithm of a program. So let's say I have an example here. This entire pseudocode, you don't have to understand what it means now. Basically, talk about how we can sort an array of numbers. So pseudocode is the standard method of showing an algorithm. Computer scientists love to use this. It uses English keywords that are very similar to those used in high-level programming language. This is important so that after the user written this pseudocode, they can translate this pseudocode pretty easily into any programming language they want. It's like a framework that you need when you are writing an essay like that. And it's not bound by the strict syntax rule of a programming language. And the person reading the pseudocode does not need to have knowledge in a programming language. So you don't have to know Python or Java to understand this code. So this is the reason why it's used in various computer science research paper, because different computer scientists, they learn different programming language. So by using pseudocode, this information becomes universally understandable. So to understand how to write pseudocode like this, we first need to learn the different elements of the pseudocode. You'll find things that are very similar to the flowchart. So let's start off with assignment statement. So a value is assigned to items or variable. So this value will usually be assigned to variable. If you remember the question that we do in flowchart, we kind of assign this variable n1 to whatever the user has keyed in. So think of the word variable as a box here that stores a value that we can refer to it whenever we want to. All right, and the value on the right here, it can have one value or multiple value. Let me show you how to do this. Let's say you want to give the variable x a value of 5. You can write in this way, which the 5 is pointed to the x, which means it's stored inside the variable, a box here called x. Similarly with the name Adam. And if you would, you can also assign a variable with multiple values by using something called the operator. By the way, this is the multiply operator. So by doing x equal to 5 times 6, the x variable here will contain the value 30. All right, the name here will contain the variable hello Adam, and so on and so forth. So here are some of the operator that you might find useful whenever you want to assign, create a variable. So the benefits of having a variable is that instead of doing whatever that is on the left hand side, let's say I want to output all this value many times, instead of copy and pasting this value one by one, I can assign this value, this random string here, to a variable called name. And whenever I want to refer to this name, instead of outputting the entire string again and again, I can just say I want to output name. And then the computer program will find out whatever that is stored inside the name variable and output accordingly. So let's try to do some exercise to explain this entire pseudocode things. I know it sounds pretty abstract, but let's try to do this. So your task is that, so let's say I have a variable called cost. Again, picture it as a box here that has a variable 5. And this the name that we give this box is called cost. And by using this variable, you need to create the following variable using different operator. So let's try to solve it. My working space. So I want to create a price variable. It says this price variable should have twice the value of cost. Well, one common mistake is that people will just write, okay, 10. Well, this is not what we want to do because cost can be any value. We want it to be dynamic, which means whatever cost is, I want the price variable to have double the value of it. So what I'm going to do is that I'm going to write cost, price is equal to cost multiplied by 2. You can always refer to this mathematical operators to find out the symbol for a different operation. All right, multiply here is a star. So I'm going to write price equal to cost multiplied by 2. And the second part, tax is equal to 12% of the total price. So let's create a tax variable that stores the tax value is equal to 12% of the total price. So what I can do is that I can use a price here, multiply by 0.12. So that's the way we calculate a portion of the value. And followed by another value, selling price. And it's calculated using price plus tax. So let's do this, price plus tax. And the fourth variable they want us to do, the gender variable that contain the value m. So I will write gender here, assign it to have a value of m. And another variable, chosen variable, assign it to a value of false. So this is how we can assign variables, either using just one value here or multiple value by using mathematical operators. So you might not find it. So this is the answer. So another stuff besides and one value, we can also assign multiple values to one variable. This is what we call an array. We can assign an array to a variable. So what an array is, think of it as a container that can store multiple items. A container that can store multiple items. What we have done so far is that let's x equal to 5. Let's say we create this variable. We are saying that this x variable has one value called 5. But what the array variable does is that it creates, for one thing, for one variable name, let's say my class, I assign it a value of an array of value, a list of value here to this one variable. So for instance, in the my class variable, you can store a list of names of your classmates or your students into just one variable. So, and this is how the pseudocode, the syntax that we use to declare an array in pseudocode. First of all, we use the declare keyword, followed by the name that we give to the variable, and the array keyword. 1 to 10 here means that we are creating an array of size 10, which means this variable can store 10 values of string. String is a data type, basically means like name here. An alternative could be an integer, all right, which store number. So you need, when you create an array variable, you will need to first declare what this array stores, what data type it stores. So a way to access one particular value in an array, so sometimes we just want to access, let's say, the third item in the array, we can do this. We can just draw a square bracket, all right, followed by a number. Let's say I want to do my class. I want to assign a value of my name, James, into this array variable. What I can do is that I use the variable name, my class, followed by a square bracket with a number inside denoting the position, and then put in my value. And this James will be stored inside this array variable. So this is how we can access a particular element in an array. So here we have a question here. Your task is to create an array variable called marklist. The array size is 20 and it stores the integer data type. How to access the 12 elements. So I will just draw it here. I have not prepared a space. What we can do is that we can write declare. Let's declare a variable called marklist. Basically store a list of marks obtained by a student. Marklist. And we write down the array keyword. So the array size is 20. So I'm going to write 120 of string. Because it's storing marks, I'm going to write integer data type. Integer. And how do we access the 12 elements? It's easy. We can just do mark list. Let's say I want to output the 12 element. I'll just put output mark list followed by a square bracket number 12, and it will show me the 12 elements of the array. So that's just some understanding. Okay, so let's move on to the next elements of pseudocode, which is the input and output. Input keyword is used to ask the user for an input, and the output keyword is to use to display information on a screen. So it's again very similar to what we learned in flowchart. So I have an application here that I want to show, which I have written the program in Python, because one thing I realized when people learn pseudocode is that they can't picture what is actually happening in the program. So I will move on to this application here called REPL. Let me uncomment this. So this is a platform where you can write down your code to just show how the program is working. So remember the program that we does, we create a bunch of variables for cost, tax, and price. So when we write it, all this code in programming language, this is how it works. So let me run the program. It will prompt me to enter the cost. So this is the input component of the pseudocode or the flowchart. So I can just enter any numbers. So let's say my cost is $10. And what this program does is that it will calculate for me the selling price, which you can got it by multiply the cost by 2 and then sum it up with the text variable. So we have this, since this class is not about programming, we'll do more in chapter 8, but I'm just showing it here so that you know what this pseudocode will do when they are being translated into a programming language like Python. All right, so this is how it works. As you can see, again, I want to emphasize the benefit of using variable here is that it can be dynamic. Let's say I were to run it again and I were to type in the value 1000. And depending on the cost value, different output will be produced. So this is the power of programming and the power of input and output code here and variable. All right, so let's go back to this code. First of all, what this code does is that it asks the user for an input. So when we write the keyword input cost, the program actually does two things. First of all, it asks the user for a number, for a input. And after that, the second part of this line is that whatever the user key in, it will be stored inside a cost variable. A cost variable. All right. So let's say I key in the value 1000. The cost variable will now contain the value 1000. So if you look at the second line of code, price is calculated using cost multiplied by 2. So what this program does is that we'll look into the cost variable and see, all right, what is inside the cost variable, and then multiply it by 2. So in this case, the price variable will have 2000. And followed by all these lines of codes. And last but not least, we learned the new thing is the output variable. Not the variable, the output keyword. It will output whatever the program has calculated, just like what I have shown you in my program. So that's the input and output part of the application. So let's move on to conditionals, which is an element of the pseudocode that allows the algorithm to do different things depending on different input and scenario. Again, you can relate this back to what we learned in flowchart, the decision variable element. The keyword that we use is if then else and case of otherwise and case. I'm going to explain it one by one by first showing you the code followed by a proper dissect of how this keyword works. So just try to read this code here. We have this bunch of code, and as you can see, it's pretty similar to what we read in English. So you can roughly get the idea of what this is doing. It basically first asks the user, hey, what is your name? What is your age? and if the user age is less than 18, then it will output something called a child. If not, the statement under the else element will be output. We say is, and you are an adult, you are a child. If, then, else, and if. So if we were to properly dissect it, let me explain. If you look at those words that are highlighted in red color, these are the keywords, which means you have to include them every time you write a conditionals. If, then, else, and if. All right. So the word after the word if is, we call them a condition. A condition will produce a value of either true or false. If you look at our example here, if age is less than 18, so in this case, it can either be a true or false scenario. Either you are younger than 18 or you are older than 18. So we have a true and false value here. And followed by the then keyword, which means the condition is met. If age is less than 18, then we output the child name. So this is the part. So let me use another color. The code that is encapsulated by this rectangle is the code that will be run if the condition is true. But if the condition is false, this will be the code that will be run. All right. And after the end if statement has ended, we'll just use an if statement to signify the end of the algorithm. All right. So this is how we use the if then else statement. So to use this statement better, you will need the comparison operator, like the greater than, less than, equal to basically create the condition here. The condition here. You need to use the comparison operator. So again, let's try out a question. So using what you learned, try to do through this before I explain the answer. You can pause the video, because ultimately there's no use remember all the syntax if you can't use them to solve a problem. All right. So let's try to solve this problem. Our question is that we need to write a program in pseudocode that asks the user to input his height and weight, and if the height is greater than 170 and weight is lighter than 85, we'll output a message: you meet the requirement, otherwise you need to be taller and lighter. So let's try to write it out. First of all, we need to ask the user to input his height and weight. So I'll just write an input keyword, again, remember, a weight. So this does two things. It asks the user for his weight and then store this number into the weight variable. Okay, we have a weight variable here. And then let's input another variable called the height. So this is the point where we want to make a decision. We want to use an if statement. So we'll do this if, let's use another color for condition. The condition for the question is that the height is greater than 170. So just write height is greater than 170. But that's not the only condition that needs to be met. The other condition needs to be met too. We'll use the and keyword to state that these two conditions need to be true in order for the whole condition to be true. And weight is lighter than 85. If that is so, we'll have the then keyword. If this condition is true, according to the question, what we need to do is that we need to output the message. Output, you meet the requirement. You meet the requirement. If not, we are going to output another message, else, you need to be taller. You need to be taller. I'll just skip this to save time. And followed by the and if statement. And that's it. That is how we use an if statement to write a program that makes decisions based on what the user key in. So this is the answer. Hopefully you got it right too. If not, you can just do it again. So let's move on to another way we can do conditions. Another way program can make a decision is to use the case of, otherwise, and end case statement. So here we have a code here. Again, you can read it too and see whether you understand it before you dissect. And how this works is that we have three different keywords here. First of all, we have case of. Basically, look into the variable. So first of all, this program asks the user what food do you want to buy, and it stores the result into this variable called food to buy. And if you look at these two lines here, these are the options that the user can key in. So if the user were to key in the word Milo, we would do this line of code, the blue color block boxes. This line of statement will be executed. And if the user were to key in the word biscuit, this is the word that will be output. The code will be run instead. All right, what if the user doesn't key in any of these two values? Let's say he key in, I want ice cream. In this case, every other input will fall into this otherwise condition, in which they will need to output the canteen does not have this food, and followed by the keyword end case. All right, so again, let's do an example to show you how this works. Our program's problem statement here is that we need to ask the user to input his or her grades, and if the grade entered is A, we output the message excellent, B, not bad, huh? C, fair, and D, why do you sleep in my class? For all the other values, we output invalid input. So how can we do around this? Again, let's start off with the input. We can write something like the input. Great, let's give it a name of great. And we are going to use the keyword of case of. Case of, followed by the variable that we want to look into when solving this, when making a decision. And the variable that we care is the variable grade. And we have different conditions here, right? So if the condition is A, oh, I've used the wrong pen. The condition is A, we are going to follow by a colon. These are all the syntax that you need to remember. Colon, output, we'll do output excellent. And if the grade is B, we'll write output not bad, huh? So these are all the options, C, and you do fair. And I believe you can see this is pretty easy and not very hard, quite straightforward. And D, we'll write something like, why you sleep in my class? I'm gonna skip that to save time. And here's the interesting point. We need another keyword called the otherwise keywords, in which if the user enter a value, like besides A, B, C, or D, we are going to do the otherwise point. I'm going to output invalid input. So last but not least, we can end the statement with an end case statement. So that's the end of this question and how we do this. So this is the answer. You can check it out. So having done the conditional pseudocode part, let's move on to the iterative statement, in which it is one component of pseudocode that is super duper useful, and which they allow the algorithms to repeat certain action without writing it over and over again. So let me explain. We have three different types of statement here. I'm going to explain it one by one. So the first statement that we will be using is the for to next statement. It is basically used when a set numbers of repetitions are required. That means we know how many times do we want to repeat. How many times to repeat. So I have a code here. I'm going to dissect it, and I'm going to show you in Python code the power of this. So we have a few keywords here. Is that first one is for, to, and next. All right. So what this does is that for counter equal to 1, what we are doing is that this, okay, let me just clear all the marking. or use a blue color pen. So what this counter one does is that, hey, we are telling our program, hey, I want to create a variable called counter and store a value of 1 here, all right? To just initialize the stuff, my counter value is equal to 1. And let's look at the first line of code. For counter equal to 1 to 10, what they are saying here is that I want the program to run continuously, repeatedly, until the counter value reaches 10. So this line of code, the second line of code, will be run repeatedly until the counter value reaches 10. All right. So, and followed by the third line, we're going to increment that counter by 1. So how it works is that, let me clear everything, is that at the beginning, the counter value has a value of 1, and you're going to run this code. So the device will output a value 1 here. And then we'll move on to the next line where you say next counter. So this line of code basically increment the counter value by 1. So if you look at this counter variable, we can increase it from 1 to 2. So now counter have 2. And instead of moving down the code, what this program does is that it will go back up to this first line of code. It will check. Now my counter value is 2. It will check whether this counter value is equal to 10. So since my counter value is 2, it's not equal to 10, it's not going to do anything. It will continue to the second line of code. It will output the value 2. So output that value 2. And then it will go back to the third line of code where we call next counter. Then the counter value will go to 3, 4, 5, 6, 7, 8, where it will be output continuously. And until a point where the counter value is incremented until 10. So let's look at the first line of code for counter 1 to 10. At this point, the counter value is already 10. And instead of executing the second line of code, what this program does, if the counter is 10, it will skip the code here and instead do whatever code that is here. And this is how a for loop works. So I'm going to show you how it works in Python. Let me delete the first part of the code to show you how. So I have written this for loop codes in Python form. And if I were to run this code, although it's only 2 lines of code, you can see that the value from 1 to 9 is being output, which means this in line find, the keyword print counter is being executed over and over again until the counter value is equal to 10. And if I were to increase it to, let's say 100, okay. All right, if you were to replace this 10 here into 15, you're gonna get 1 to 15. Of course, there is some syntax spec here. If you write 10, the Python is going to run until the word 9. We'll definitely look more into how you can write this codes in Python in chapter 8, so stay tuned for that. So this is one iteration, which is the for to next iteration. We already discussed this. So here we have a code here. So try to read this and see whether you can grasp what it is doing. So I have for counter from 1 to 10, which means I have a counter value of initial value of 1, and the 10 is the ending value. And for each iteration, I'm going to output, hey, please enter the name of the student. Output keyword. And I'm going to say another thing, hey, input anything. And then store it into this student name counter. As you can see, we have a square bracket here. This means that this is an array. So what this code actually does is that it asks the user for 10 names iteratively, and then place each name into the array. So if you can see, the initial counter value is 1. So let's go through the code. Output, enter name of student. Let's say I enter a name called ABC. Input, and whatever I key in here will be stored into student name, square bracket, counter. So AB, since my counter value is equal to 1 here, so I'm actually inputting my counter into student name 1. Remember, this is how we refer to a variable. So my ABC will be inputted into this array. And when the next counter, it will increment the counter value by 1. So my counter value is equal to 2. And if you were to input your value again, let's say you put DEF. Sorry, I'm not very creative. And DEF will be entered into the second element of the array until the counter value reaches 10. And basically this code populates the entire array with all the values. So this is just one method of how you can use iteration. And let's proceed to another form of iterative statement that you can use, in which, in this case, the number of repeats is not known, but this statement is completed at least one. So we have two keywords, the repeat keywords, until. It's pretty intuitive. What it does is that basically we repeat whatever code that is written here until, the keyword here, until option is equal to -1. Option is a variable. So let's go through this program. First of all, the program will output, hey, hello. And then it will ask us for an input. And the input that we give will be stored inside this variable called the option variable. And if we were to key in, let's say I key in the value 5, okay, receive. And we'll move on to the next line. We'll check whether option is equal to -1. If it's not, again, this line of code will go back to the repeat here. And until I key in, it will say hello again. Until I key in the value -1, option equal to -1. If the condition, again, this is a condition here. If its condition is -1, yeah, then the code won't go back to the repeat statement again. It will just move on to whatever code that is beneath it. So that's the end of it. Let's repeat until. So here we have a question. What does the code below do? Pause the video and see whether you can get it. All right. So what this does is that in each iteration, we ask the user for a mark. So if you can see this code, this chunk of code that's being repeated, and we just keep asking the user for a mark, and then we sum it up with in the total variable, and the program will stop when the user key in a value -1, as shown by the condition here. So one special thing about this statement is that this code will run at least one time, because the repeat statement is here. And let me erase this. This code will run one time regardless of what the user key in the beginning. All right, because the condition will only be checked here. All right, if I were to create a variable called mark equal to -2, it will still, this chunk of code, part A here, will still run despite the condition not being met. Sorry, because the condition is not checked until this chunk of code is run. So this is one thing. Repeat until run at least one time regardless of the condition. So there's another type of iterative statement, the third type, is that where the number of repeat is not known, is that it might never get completed even for one, which is the while, do, and while loop. The same program here, we ask the user for mark until and sum it all up until the user key in the value -1. So you can see here we have three keywords: the while keyword, do keyword, and end while keyword. So it reads pretty intuitively. What I say here is that while mark, this is the non-equal sign, while mark is not equal to -1, I'm going to run this chunk of code. I'm going to sum up the total mark. I'm going to ask you to input your mark again. But if the mark statement is equal to -1, I'm going to jump straight to the end while statement. So this is the breakdown. This is the condition which determines whether the loop continues. And this is the chunk of code that will be run if the condition is met. And this is the end while keyword that signifies the end of the key loop, the while loop. So we have another question here that says we are going to ask the user for a number iteratively. All right. Then the square of the number will need to be stored in an array, which means if I were to key in a value of 3, the square of the value 3, which is 9, will be stored into the array. The program shall halt when the user enters the value 0. So to do this, we need to first declare an array, so which is shown here. So if you notice, we have a different kind of array here. So if you don't remember, this is the keyword. This is the name of the array. And this is the keyword again. If you look at this array, it doesn't have the end value. This means that this is a dynamic array, which means we don't know how big the array should be. So we just create an array that can be of unlimited size, which is doable in Python nowadays, and of integer, which means we want to store an integer value. So you can see here, I've placed an illustration here to show you what is being created, an array of unfixed size. So I'll create a variable called counter1 as my counter, and then I'll ask the user for an input. Hey, can you give me a number? Again, remember the specification is that we square the number, store it into an array. And then we just do this code. While the number is equal to 0, we'll do this. So, and let's say that the user first key in the value 5. So what the code does is that it will check, is the number, while the number is not equal to 0. Is it not equal to 0? Yeah, we got the 5. So what it will do is that it will run this chunk of code, point A here, and it will assign the value number power of 2. This is the word for power. Basically, we're doing this, power of 2, which is 25. We are going to assign it to this square num array in the counter variable. All right. So this counter, we know that the value is 1. So in other words, this value 25 is going to be stored in the first position of this array. Okay. And after this step, we are going to increment the counter by 1, because in the next iteration, we don't want to put that value into this position 1 again. We want to put it into position 2. All right. So again, we'll ask the user to input a number after the first step. So let me first erase this. I'm going to put 25 here. So let's say the user keyed another value, let's say 10. Again, this algorithm will check, is the number is the number not equal to 0? Yeah, 10 is not equal to 0. I'm going to run this code again. Number power of 2. I got 10 to the power of 2, which is 100, will be stored, assigned into this array in element counter. So remember, just now we just incremented the counter. So counter value is now 2. So I'm storing this 100 into the second position of this array. And again, I increment the counter by 1, and then I'll ask the user again for a value. Again, I need to erase this. So now, let's say the user doesn't want to enter a value again. He'll just enter value 0. Again, this loop will check, is the number not equal to 0? No, it is equal to 0. So what this does is that instead of running this chunk of code, this code will go straight to the end while statement here. So the program will terminate and the program won't be running again. So this is the way we use iterative statements and conditionals. And I understand that in the beginning, it might be very difficult to digest it to even solve the problem. But just like mathematics, for programming and writing codes, you need a lot of practice to know when to use the right syntax. So my advice for you is that just try to pause my video whenever I do exercise and try to do it yourself and cross-check with my answer to check whether you got the correct answer or not. All right, so that's the basic part of pseudocode. We'll definitely go through more of it in chapter 8 when we can write it in Python where you can see the real effect.